Thank you very much. It's great to be here, everybody, and many thanks for spending your time with us today. I hope you're going to find this to be a good use of your time. This is a great opportunity for us to learn a little bit about what Autodesk is doing and how we see market trends and the future of making things. It will also help shed some light and better understand how Autodesk sees the market and give you some insights into what we're doing to help our customers enable their competitive diversity. There are a few topics I want to cover in this short presentation, things such as the manufacturing industry trends, where we are seeing at a macro level, Autodesk's ongoing investment into the current manufacturing portfolio for things like subtractive, additive, simulation, and generative design, and how we're delivering the next generation manufacturing platform called Fusion 360, and why you should be paying attention to the opportunity it offers you. I hope it'll make you think about some of the challenges and where we could potentially work together to find solutions. And with that, we'll get started. Let's think for a minute of all the current initiatives and pressures we're all facing in our day-to-day business and personal lives. On the negative side, there are some challenges. Here are some of the challenges. We have things like an increasing world population, global climate change, carbon emissions, an aging workforce, increased global competition, and disruptive business models. On the positive side, we have a lot of opportunities: infinite cheap computing power, digitalization, new digitally native workforce, new means of manufacturing and materials, automation, connectivity, AI, and machine learning. These threats and opportunities are impacting both you and your customers. The question is, how will you respond? These macro industry trends are impacting manufacturers in three areas: the nature of products, the things you make, the technology available to help you make these things, and the nature of the work your people will be asked to do. The things you make, whether it's products or buildings, need to be better suited to human needs. They need to be more customized, more configurable, and more connected, and ultimately more valuable to the customers and their producers. We are seeing the rise in product as a service and the Internet of Things being used as a way to collect information that can be mined for insights to create more opportunity for better products and additional revenue streams. In the realm of making, new technology is being introduced, things like 3D printing, hybrid manufacturing, flexible and configurable factories, and new advanced materials. And work is changing as the processes of design and making converge across industries, and industries themselves are converging. The way we make things is changing. Construction is becoming more automated, more like manufacturing, with prefabrication and modular building components. Teams and supply chains are increasingly connected. Digitally native workers expect a different experience, and they demand access to the latest technology. Think about how you will attract these people to work for you. New types of jobs are being created to support these things, from data analysts to chief innovation and chief digital officers. Over the past 15 years or so, we have invested over $1 billion acquiring world-class technologies in the advanced manufacturing space, covering additive, subtractive, simulation, materials, and electronic disciplines with companies like Moldflow, Delcam, and NetFab, to name a few. This brought a vast array of technology and expertise into Autodesk. We can now provide our customers with a broad, best-in-class portfolio across advanced manufacturing processes and needs. From design exploration through optimization and simulation, additive and subtractive manufacturing, to inspection and robotics, allowing our customers to plan, program, and produce anything using an Autodesk solution. At Autodesk, we have a manufacturing center of excellence. We have the broadest, most comprehensive, best-in-class manufacturing solutions available today. And our customers are benefiting from the investments we are making in the expertise of our people, with over 600 developers, plus our expert technical consulting team, and a growing specialized local partner network. Ongoing development and integration of our solutions and our advanced manufacturing facilities around the world. So that's where we are today. We talked about the threats and opportunities facing manufacturers. How do we at Autodesk provide you with not only the tools you need today, but also the tools you will need tomorrow, and enable you to seamlessly adapt as your business needs change? We want to help you connect your workflows and automate your processes. and network with your entire supply chain. To do this, our solution is a single platform with your data at the center of it. It provides a seamless connection to manufacturing. It automates repetitive workflows. It empowers decision-making through a bidirectional transparency and adds intelligence based on your engineering criteria. And really what you're looking at is it networks to everyone's process. It starts with creating a platform where design, engineering, and manufacturing can seamlessly coexist. With this platform, users will be able to access all the technology they need available on demand, have the ability to collaborate with all stakeholders from design to manufacturing, connect to suppliers and service providers, and stay connected through the whole development timeline. We call this Fusion 360, and we do believe it is a game changer. It starts with creating a excuse me. Fusion 360 allows you to automate repetitive workflows and streamline design and manufacturing process. It adds intelligence so that you can make more informed decisions, and it lets you explore more options faster when it comes to design and manufacturing process, allowing you more time to innovate. Bringing all these technologies together in a single, unified, collaborative environment removes the burden of seeing the data and different technologies separate from manufacturing, and it allows the ability to focus on the problem at hand. We believe such an approach will solve the future challenges for manufacturers by making the most of the opportunity to harness all of the new available technologies. As I said before, it breaks the relentless linearity of process. It increases the transparency of manufacturing early in the design process and allows you to automate repetitive tasks. It connects data from and to machines with a digital thread, and it provides a single connected instant-on platform. Such an approach is critical to helping to generate dramatic productivity improvements and spur innovation. Many thanks, everybody, for allowing me the time to walk you through this. I hope it helped you understand the Autodesk manufacturing strategy, things like the macro trends, the drivers that we're seeing in industry, our commitment to the great tool set we already have, and how we're investing to provide you with the tools that you will need for the future. I want to take a minute and introduce my good friend Ed, who's going to lead us through the technical portion of the presentation today. So without further ado, I'll pass it over to Ed for the presentation.
All right, excellent. Thanks, Chris. So we're going to dive into FeatureCAM today. So Chris gave a great overview of kind of what Autodesk is doing and the work that they're doing to build products that are going to help you out even more in your day-to-day manufacturing and really help you innovate and beat out the competition. So thanks for that, Chris. I'm going to jump into some detail on FeatureCAM. I think that's what most everyone is here for today. So let me go ahead and share my screen here. All right. So FeatureCAM is one of kind of the best CNC softwares for automating your processes. So what this allows you to do is take your part, and rather than have to go through and select your tool, select your feeds and speeds, select all the contours you want to machine, make sure that all of your settings are correct, generate the toolpath, and then on to the next. It's going to automate that workflow. So it's going to help use the parameters you give it. So you're going to provide it with the tool crib that you'd like to use, the parameters that you typically machine with. So, you know, what kind of step overs do you use? What is your preferred ramping strategy, your lead in, your lead out, all of those key parameters you can provide the automation and guide it so that it's not just blindly automating your workflow. It's going to do it intelligently so that you can get programming times down so you can really quickly program parts. But also you're going to be producing consistent results because you're using the same strategies, the same tools each time. There's not going to be errors made by you know, those human errors that occur as you're programming just because you're not paying attention or everyone has their own sort of preference. This helps to kind of keep your programs and your results on the machine more consistent. So the way that FeatureCAM works is that it's going to take your part that you provide it. So this can be a solid model. You can bring it right over from Fusion 360. You can also bring it in from something like Inventor, or if you're using another software like SolidWorks or ProEngineer or CATIA, you can take those solids, bring them into FeatureCAM, and what it's going to do is it's going to recognize all of the features. So that's going to be something that is made up of associative operations. So essentially, it'll look at a pocket and say, okay, I need to rough out this pocket and then finish the sidewalls and the floor of the pocket. Or for a hole, it's going to recognize that it's a cylindrical hole. It needs to spot drill and then come in and do a through drill or a pecking cycle to machine that away. For a turned part, this might mean that it needs to come in and do an initial roughing pass to create the profile, then come in and do some grooving. It identifies the three-dimensional feature, and then it's going to use that to guide what toolpath is selected and how it approaches the actual CNC programming. So how can this help you out? What are some industry challenges that you're facing right now where this could really assist you? You know, right off the bat, the first thing a lot of people think of is programming times. You know, so you know, you probably have a tight schedule. You know, it's best if you can get your customers their parts or get your own company their parts as quickly as possible. It makes everybody happy. You know, maybe you can even increase your profits that way. So programming time is always critical. This is going to greatly improve your programming time, which means you'll be more productive. You're cranking out parts faster. You're using your machines more often. You know, the machines aren't sitting idle waiting for the next program. You are providing machines with a maximum workflow, maximize your ROI on those expensive machines, and that's always going to be the goal. Increases in how complex the parts are. So, you know, we're innovating every single day, and the parts are going to keep getting more complex. And the great thing about that is you can handle more complex parts, which means you can create better designs, but also you're going to have more confidence machining those complex parts because you have the automation built in, so that once you program it the first time, it's going to be exactly the same the next time. And then new technology, maybe you invested in a new fancy machine and you want to feel confident programming it, and you want to program it efficiently. FeatureCAM is going to help you do that and help you really maximize how you're using that machine, using all 5 axes, using every single feature that it has. You can prevent some model rework, so you don't want to take a part off your fancy CNC machine and then have to go and put it back on for additional machining or do manual polishing, things like that. That just doesn't make sense when you have a high-end CNC machine. So those are things that can be avoided with consistent, efficient toolpaths that are going to maximize your machine. You can optimize your results. So maybe you're manually programming parts right now. You might as well upgrade. You know, there's a lot of softwares out here that are very intuitive, very easy to learn, and they will learn your preferences so that you can get high-quality parts exactly how you want them. And then also sharing knowledge, and this is really critical when you have you know, maybe a full programming department where you have a lot of different employees. This allows you to kind of share knowledge amongst employees, but also make sure that if you program a part and you like the way you program it, you can save those settings and apply those to the second, third, fourth time you make that part, or you know, maybe a month later, customer comes back and they say that they need another component. There's no guesswork involved. You know how you programmed it the first time, and you can produce those same results again. So 3 words come to mind with FeatureCAM. It's fast, it's intelligent, and it's comprehensive. So it can allow you to program a wide variety of machines, and it's also going to do it with built-in automation and intelligence. So typically, you know, your workflow for programming CNC machines is going to look something like this. You're going to be importing your geometry from whatever software you're using, identifying your features, simulating, making sure that everything looks correct, and generating NC code. So this is kind of the process that FeatureCAM uses and that it automates. So we're going to cut down programming time. We're going to meet our tight delivery schedules, improve our time to market, cut some costs in that aspect. And another great thing is that if you're just kind of preparing an initial quote and you want to know generally how complex it is going to be machining the part and also how long it should take so you can give a nice accurate estimate to your customer, this will allow you to create those quotes quickly because you're not spending all day programming a part you may not even end up producing. It allows you to just crank out a good estimate that you can provide the customer and get that turned around. So we can use our knowledge to build what's called the machining configurations and machining attributes, which I'll show you guys in the software in just a moment. These attributes allow you to customize every single aspect of your toolpath, whether you're doing drilling or milling, surface finishing. It will allow you to customize all of your settings so that when it is automating, it's automating the way that you would want to program. So it's kind of like your best friend. It's going to learn what you prefer and then machine your parts efficiently in that manner. So let's take a look at what FeatureCAM can do, right? So if you're doing milling, you're in a really good spot with FeatureCAM. You can do some 2.5 axis simple prismatic parts. Maybe you do some more 3 axis, maybe some 4th axis rotary. You can do full 5 axis, whether it's simultaneous milling or 3+2 positional. You can get into lathe work as well, so just your simple 2 axis lathes, but also multitasking. So if you're doing turn mill, live tooling, maybe you have a Swiss type lathe, maybe you're doing dual spindle operations or simultaneous turning. You can cover that with FeatureCAM. Probing, so you want to come in and do some surface inspection and probing, great. It has that capability. And maybe you have a wire EDM as well. So maybe you have a combination of machines on your floor. You want to be able to program them all with the same software. FeatureCAM is great for that because it covers things like wire EDM, multitasking lathes, and milling all within one interface. You're not having to program your machines with 3 different softwares. You can kind of contain everything within one sound interface. So just a quick overview of kind of what you would see with a traditional workflow. So a lot of steps here. Every single operation you create with a typical CAM software, or even if you're doing this, manually, it's going to even be more steps than this. But let's say you just have your traditional CAM software. You come in and you've got to select all of your operation types, boundaries, toolpath, tools, feeds and speeds, step overs, step down, simulate, generate your G-code. You have to do that for every single operation. And then maybe you have multiple setups for a 5-axis part. Then you have to do that again for an additional setup. So it really starts to become time intensive, and the more time, the more button clicks you have to make, that means the potential for error and the potential for less consistency. So a lot of steps here. It feels a little bit outdated, and if it does, that's because there are softwares like FeatureCAM that have automated this process. So something that's more process-based is basically going to be a little bit simpler, where you're just identifying features and then it's going to choose the correct process for that feature. But there's still a lot of things you need to verify. So, is it using the correct operation order? Are we using the tools that I actually have in my tool crib? Are the feeds and speeds comfortable for that material? There's a lot of things to validate. So FeatureCAM takes it even one step further, and it's going to automatically recognize your features. So that takes out several steps. It automatically determines your tool from your tool crib and finds the correct size, correct feeds and speeds based off your preferences and based off of the material. It's going to split out roughing and finishing operations and create separate toolpaths for those. It's going to generate the toolpath, and when you simulate the toolpath, it generates the NC code in the background for you. So it even automates the NC code generation process. So it's really an incredible software. It streamlines things, which again is going to speed up your programming time, improve consistency, and you're going to be reducing the errors that you're making. All right, so I think we've all had enough PowerPoint for this morning. So I'm going to jump into a technical demo. If you have any questions, remember, make sure you send them in the chat window, and we can get to your questions afterwards. But I'm going to show you a couple really cool things you can do with FeatureCAM, kind of starting from the start point here, bringing in a model. So we've got FeatureCAM. I'm actually using 2021 right here. And the way that it's set up is basically you can create a new document based off of the type of operation you're running. So I'm doing milling today. I'm going to be showing you a 5-axis part where I'm going to be using some 3+2 positional. I'll talk a little bit about machine configurations as we go through. But generally, your first step is going to be, first, let's just create a document where we can bring our part model into. So in the document itself, either once you bring the part in or before you bring the part in, you want to make sure you have your tools laid out. Otherwise, you're going to be kind of going back and forth. It's best to kind of get your tools set up prior to building your operation list. That way, you're not having to go back and regenerate a bunch of times as you change your tool crib. So usually what I'll do is I'll go into the tool manager, and I've created a crib already that we're going to use for today's demo. So it's got a bunch of different end mills and ball nose mills. It has some taps. It has some twist drills, quite a bit of different components in here. But if you want to build a new crib for your machine, you could build a crib based off machine or based off material, whatever you want to do. So let's say I want to create a new crib for all the tools that I use on this new machine. I'll go ahead and click on New Crib here. And we'll just call this my new machine crib. So I got this new fancy. I'm actually simulating with a Haas UMC 750 today. So maybe it's my Haas UMC 750 crib. I'll go and click OK for my new machine crib here. And then I can pull from an existing crib. So if I already built a crib, I can use tools from there. Or there's a bunch of tools you can load in that come with the software that give you at least a good starting point, and then you can continue to customize those once they're in your crib. So basically what I'd probably do is just go through and say, all right, well, I want to grab a couple of end mills here. So we'll just sort by diameter. Maybe I just want to grab a couple of, maybe just like an 1/8 inch diameter end mill. We'll add that. Maybe I want to grab a 3/16, maybe a couple bigger end mills, like a 1/2 inch or 3/4. So grab a 3/4. We'll add that in there. So I've got a few end mills. I can then go and filter by different groups. Maybe I also want to look at a couple of twist drills in here. So I'm going to grab a couple of twist drills. Maybe I want to grab a 1610 here. Let's grab one for a 1/4 inch. Let's grab a 1/4 inch twist drill and maybe a 3/8 twist drill here. So grab a couple of tools, build your new crib out, and then when you go to create a new automated strategy, it's going to use whatever crib you have selected in the tool manager. So if I have new machine crib active, it's only going to select tools from this crib. If I have my demo crib active, it's going to pull from that crib. I also have a couple other ones in here. So once they're in your crib, you'll notice then I can click on properties over here. So maybe I want to customize one of these end mills that I had in here earlier. So I want to customize this 1/8 inch end mill. I'll go ahead and click on properties. And it's just going to open up the editor where I can change the end mill properties. So maybe the overall length is a little bit longer. Maybe it's a 2.5 inch overall length. And maybe it has 3 flutes or 4 flutes instead of 2. You can go through and customize that. You can customize the holder dimensions and how it's being held. So you have full control over your tool crib. Once you've built it, you don't have to go do it again. So I'll go ahead and edit that tool. It updates it, and I'm off and running. So it's kind of a tedious first step, but it's an important first step to go through and build your tool library based off of the machine you're using or based off of the group of tools that you have in-house. So we're going to be using our demo crib here. We'll just go ahead, and I'm not going to save that in the background. So right now, you click on tool crib. I'm using my demo crib, so I'm all set with the tools that I need. So at this point, I'm ready to bring in my geometry. So I'll go ahead and do an import. And let's go grab our part file today. So this part file, I'll kind of spin it around a little bit. Nothing too crazy. We're not doing any complex surfacing or anything, but there's a lot of different faces that are off of the main Z-axis. So I'm going to need to do several different 5-axis setups so I can cut this with my 5-axis machine using my 3+2 positional referencing here. So probably 1, 2, 3, 4, 5, 6, 7 setups. So basically 7 different orientations that I need to position my head. So that would be kind of a pain to do with the traditional CAM software. With FeatureCAM, you'll see how incredibly easy this is. So the first step, it actually walks you through importing and setting up your stock as well. So it really helps you out in every step of the process. So first is, what is my Z direction? So we'll go ahead and click this top face for Z. And then what's my X direction? It already chose X, I'm fine with that. And then what kind of stock am I using? Well, I'm gonna use a round stock. And I'm going to compute my stock automatically. So it chooses stock based off of my dimensions of my part. I can then choose to add some additional stock on the front or the back for additional tolerance or for facing. In this case, let's just kind of use the default here. We'll just leave it at a standard size. Where is my work coordinate system? I'm just going to click on the top center. So it moves my work coordinate system to the top center of my stock block, which will be easy for setting that G54. And then the next thing you can do is set your 5-axis positioning, or if you don't want to use 5-axis positioning, you don't have to. So then once you've selected that and you go to next, it basically says, all right, you have everything you need to know for that setup. You can go ahead and click on finish. And then it jumps into the feature recognition. So it's a really smooth workflow. I don't have to like jump around and try to find what needs to be done next. It walks you through the process. So then I can go ahead and click on next. What setup am I going to recognize? We're going to start with setup 1, which is the top orientation. And it recognizes all of the features. So sometimes it's going to get it perfect. Sometimes it's going to grab some additional faces. It's not the end of the world. You can just go through and kind of manually set what you want. So FeatureCAM is broken up into 2 sort of strategies: automatic feature recognition, and then sort of your interactive feature recognition. So automatic feature recognition, it automatically pulls everything for you, and then you just sort from the list. Interactive feature recognition, you can go through and choose exactly what features to machine and what strategy you'd like to use. So it's a little bit more customizable, where automatic feature recognition kind of does most of the hard, heavy lifting for you. So I'm just going to go ahead and choose, I want the facing operation, and I want the machining operation to cut out this M in the middle of the top there. And I also want to cut the square boss at the top, but I'm not going to cut anything on the bottom because my diameter is already cut out. And I'm going to machine the other half of that part after flipping it around. So I'm holding the lower portion in my vise, so I'm not going to machine that first. So I'll go ahead and click on finish with just 3 of these operations selected, and boom, just like that, I have my roughing pass, my finishing pass already set up. The only thing you need to do then is just check that it's correct. Looks like my side operation, it's only cutting the side and leaving a little bit of material there. So you can go through, and if there is anything that needs to be changed, no problem. I'm going to go ahead and open up that toolpath. Looks like the depth is a little bit short of the top, so I'm going to make my depth equal to 2 inches. I can then adjust my location for the Z position and add a little bit to that. Click apply. So now my feature's been moved to the correct location. So it identified the contour that I needed, but it sometimes doesn't quite get the depth right. But you don't have to go through and change like all of the strategy. All you need to do is adjust the position of the feature. Click OK. And now it selected all the tools I need. So it grabbed an 1/8 inch end mill, a 1-inch end mill, a face mill. So it's only using 3 tools, but it chose them from my crib for me. It shows the feeds and speeds based off of the material that I selected. And now when I simulate this, we're going to do a 3D sim. it's going to go ahead and generate those toolpaths, simulate it, and when I simulate it, it generates the NC code. So I'm not having to go through and create all these individual toolpaths. It recognizes the features for me, and it shows the tools and feeds and speeds for me as well. So there's no collisions, it all looks good. It runs through all the roughing and finishing. And now if you look over on the right-hand side, when I click on NC code, it's going to pull NC code using the Haas UMC 750 post processor that I specified. And it generates the NC code as I'm simulating. It gives me an approximate machining time. And it has all my NC code right here, generated, ready to go. I can click on save and just save this out to a directory where I'm pulling from. If your machine is connected to the network, you can send it straight to the machine. You can give it a program name, and then you can choose if you want to do just the current setup or all setups. So you can also break out your programs into individual setups if you want to, or just post everything together as one single operation. So just like that, in a traditional CAM software, I'd probably still be working on my facing operation at this point. But at this point with FeatureCAM, everything's programmed, it's validated, the code is generated, and I can probably go ahead and start cutting it in the next 5 minutes. So that's all pretty easy, right? But what happens when, you know, I want to customize this automation? I don't really want it to just go off and, you know, run away with it. Maybe I want to control some of the machining attributes. So there's 2 ways you can do that. Number 1 is the machining configurations. Now what this form is this controls for my FeatureCAM software. So no matter what part I open up, it uses these machining attributes. So for drilling, if I want to do spot drilling and I want to attempt to chamfer the holes with a spot drill, if I turn on those preferences in my machining attributes, it applies it to every single new part file that I open in FeatureCAM. So this is global. Your machining attributes apply to the entire software. So we'll go ahead and turn the spot drill on. Step over, maybe instead of doing a vortex, maybe I want to try out a spiral instead. So I can go through and I can customize these machining attributes, and it has everything from the step over size, your preferred depth of cut, your preferred lead-in percentage and lead-in angle. Everything can be set here for milling, turning, wire EDM, so that then when you create a new document, it knows what you want, it pulls that in. You're not having to go confirm these each time because you set it at machining attributes. All right. The other thing is the machining attributes. So machining configurations controls the entire software. Machining attributes control this specific document. So in here, I could go through and I could specify for this document that I want to use a spot drill or I want to do a specific milling operation. It will apply that to only this part file. But if you go and you open up a new document, you'll have to reset and change these again. So if you know it's something that you want to do on every single part file, that's probably where you want to use machining configurations. But if it's something that you're only doing on a specific part because of its complexity or because of the fixturing or something, that's where you want to change the machining attributes. So it's an intelligent software, not only because it just blindly automates, but also because it automates based off of what you provide it with. So the knowledge, the CNC experience that you have and all the knowledge you have in your head, you can put that into FeatureCAM, and then it is just going to take that and run with it. And that way you're not having to manually set all those settings every single time. So that obviously works great for a simple, single setup like this, but how about my multiple setups and my fixturing? How am I going to do all of that? FeatureCAM can automate your fixturing and your additional setups as well. So let's go over to my add-ins, and there's these add-ins you can program into FeatureCAM. These are included as well with the software. It's not like I have to pay anything extra for this. And one of them is called the Vice add-in. And this is really cool because it's actually going to allow me to create a vise without having to go in and build a 3D model myself. So I can go ahead and click on Import Vice once I've set my stock. And I have a different option. I can do a vise, whether it's a kind of for a rectangular part, or maybe I want to do a jaw. So I'm going to do like a soft jaw for this component. So I'm going to do a 3-jaw, 8-inch vise here. We're going to do a soft jaw. And I'm going to position my part length 4 inches above the fixturing. So I'm basically going to be grabbing the lower 1 inch of this part. This is about a 5-inch length stock. So 1 inch should be enough here. So I'll go ahead and put 4 inches for my part length from my jaw face. My part is positioned along Z, and I'll go ahead and click on import. It's going to ask me a couple questions. I'm just going to go ahead and click through here. It's going to build my fixture. It's going to size it, position it, adjust it to my existing stock, and update my part file. And now I have not only my part in here, but I also just created a nice complex fixture showing where I'm picking up the part, so I can keep track of all of my fixturing as well. So now when I go to simulate this, it's going to have the fixture in there. But another advantage of FeatureCAM is that I also get full machine simulation. So now if I go to do a machine simulation, I've loaded in my Haas UMC 750 machine file. So there's a bunch of machine files that you can use that represent your exact machine. So in this case, if I go ahead and click on play, not only is it a 3D simulation, it also pulls in my fixture, and it pulls in the full Haas UMC 750 machine with the table moving, with the head moving. Everything is included. So if I zoom out here, I have my full CNC machine. If I zoom in, you can see the head of the machine as well as the table and how that's oriented. So as I click play, it's going to go ahead and machine using not just the head of the machine or the holder or the fixture, but the entire table and everything that's included with it. This is really important when I get into my 5-axis setups, because I need to keep track of how far my table is rotating to make sure that I don't collide with my head. If you have a 5-axis machine, it makes sense to have a software like this, because otherwise you're kind of guessing at where your machine is, where your head is, and you don't want to have any collisions or damage a machine like this. Obviously that's expensive, but also it could be weeks before you could use the machine again, and that's just more production time lost. So I automated the fixture, I automated my machine, everything is all running smoothly. Now I want to create some 5-axis setups. So there's an add-in for that as well. You know, kind of like when you go to the App Store, it seems like there's an app for everything these days. FeatureCAM, there's an add-in for everything. So if I go ahead and do a 5-axis setup, all I need to do is select the face that I want. So let's just go ahead and grab this top face right here. So this face that's at like a, I don't know, a 45-degree angle to Z. And I'll go ahead and click on make 5-axis setup, and boom, it created a new setup based off of that face direction with my Z direction oriented properly. I'm going to go ahead and rename this because I don't want it to be named face 4470, so I'll just call this op2. And maybe we do one on the other side because it's identical. So I'll go ahead and I'm going to go ahead and click on this face over here. And we're going to do the same thing, make 5-axis setup, and we'll call this one, let's call it op3. I'm going to rename my first one as well. It's just set up right now. We'll rename that to be op1. So let's go ahead and recognize those. And I've already created the setup, so I can do a number of things. I could do a interactive feature recognition or an automatic. In this case, let's go ahead and do an automatic recognition again, but this time we're going to do 2 setups at the same time. I'm going to do an AFR, so automatic feature recognition, on my solid. And then which setup do I want to recognize? I already did op1, so I'm just going to recognize op2 and op3. So it starts with op2. It recognizes every feature in that orientation. So I'm going to do the face. I'm going to do the hole. And I'm going to do the pocket. So I'm going to basically clear out all the other operations it tries to create and just do the pocket, face, and hole. Click next. It moves to the next operation. So it throws those in there, and then it says, okay, well, now what? So op3, Same thing, I'm going to do the face, the hole, and the pocket, and we'll get rid of everything else. Click finish, and I'm done. So now I just added in my drilling and my machining for those 2 additional setups. So let's go ahead and simulate that. And remember, it's not just simulating. Obviously, this is a really nice, fancy simulation that I'm doing with my machine, but it's still working in the background, creating my NC code as I'm doing this. Let me zoom back out. And we'll simulate this, and this will show you that additional setup. So it's building the simulation and in the background generating my NC code so I don't have to do things twice. Once the simulation is done, I can save my G code and run it on the machine as soon as I'm ready. So I'll go ahead and pause it, and you can see that it rotates the machine and it moves the table so that I can see how this is actually going to be machined on my machine, what position the table is in, what position the head is in. So we'll go ahead and slow it down a little bit. And you can see it's positioned it using that index to the correct orientation. It's going to go ahead and rough away the part, face it off, and then do the pocket. Just like that. So if you go ahead and look around, you can see that it machined one side down, and then the other side it's currently working on right now. So we'll go ahead and jump ahead in the simulation. It's all finished. Part looks good. There weren't any collisions. And now if you look over at the NC code, again, it generated all the NC code with my machine, with the post processor, gives me a new machining time estimate, and I can go ahead and save this out and run it. So another thing is your interactive feature recognition, because there are going to be scenarios where maybe you find that the automatic feature recognition isn't working quite right, or you want to have a little bit more insight into what you're doing, and maybe you prefer to have a little bit more control than that. That's fine. So I'm going to go ahead and do the same process for these, maybe this lower pocket here. So I'll click on that face right there. I'm going to create a new setup with my add-in, and we're going to call this Op4, you guessed it. And for Op4, what I'll do instead is we'll just go ahead and just do a new feature on Op4. This is going to be a side feature, so I'll choose from my list either from dimensions, where you can just go ahead and type in the dimensions of the feature you want to add and give it a coordinate point. I can machine from a curve. So if I do a interactive feature recognition like this, it will use my setup to identify where the boundaries of my features are, and then I can sort through those and manually add the toolpath that I want. So I'm going to do a side feature, and I'm going to extract with feature recognition. So I'll click next. I'm going to select the horizontal surface that I want to use, which is going to be this one here. That looks pretty good. I'll click next. We'll add that face in there, and it creates my curve. It's basically machining everything inside of that blue area right there. I can flip the direction, so machining inside or outside of that boundary. In this case, I want to cut everything inside of that. So we'll go ahead and click on next. And then you'll notice that it shows the wrong direction. It doesn't always get the orientation right. In this case, it doesn't really know where the top and bottom of the feature is because it's really extending out to the stock. So there's not like a flat face that it terminates at. So I need to go in here and kind of select that manually. So for my top, I'll select the boundary of my stock. And for my bottom, I'll select the bottom here. So now it updates the feature to cut from the stock edge down to the bottom face of that pocket. So I gave it a little bit more information. Obviously, it still does some of the work for me, but I can choose where I want to add that feature and where I want it to terminate. Click next. If I want, maybe there's a draft angle or a chamfer on it, you can add these features to the geometry as you go. So if you wanted to add some draft, you could do that in real time with the toolpath. And then I can go through and continue to customize this. So how do I want to rough it? Do I want to use a vortex strategy, which is a high-speed roughing strategy? Do I want to use a more traditional spiral method? So I can override all of my machining attributes and configurations here because I am using my interactive feature recognition. So I'm not just blindly letting the software crank through this. I'm selectively choosing what I want. So I want to use a roughing and finishing, but I want to use a spiral traditional roughing here. Maybe I also want to finish the bottom. So I don't just want to machine it with a rough and finish on the side. Maybe I also want to finish the bottom. So I'll do a spiral to finish the bottom of that tool, or the bottom of that pocket as well. Click on next. It says it's going to use a 1/4 inch end mill for my rough and a 1/4 inch end mill for my finish. Shows me the feeds and speeds. We'll click next. It chooses the tool and it says this is the default tool. I can also search for another tool. So either I can go grab a different tool from my library. I could create a new tool specific for this operation. You have the ability to switch out the tool when you use this interactive feature method instead of the pure automatic. I can override the feeds and speeds for my roughing operation. I can override the feeds and speeds for my finishing as well as the coolant. So it steps me through the tool, feed, speed, coolant strategy for each of those, and then it says, it gives me the checkered flag. I've reached the finish line. I can now click on finish, and I've got my feature in there, so I'll click OK. So it adds it in there, and it's doing a rough and a finish pass, so I'm all set there. But you'll notice that using this method, I then have to go do the holes as well. So now I can go back in and say, all right, well, now there's another feature on here. I want to recognize a hole. Use the setup z-axis. And so what I can do is I can basically recognize these holes. And so it's going to find these holes on that face as well as their depths. I can merge the holes into a pattern, or I can do them one by one. So in this case, these are the same, and it's basically just a linear pattern of holes. So we'll merge them together in a pattern. Click finish. And then go select all 3 of these. Click finish. Done. And now it's created the feature, but again, it's interactive this time, which means I can go through and I can customize the strategy. So do I want to use a spot drill? Do I want to add a chamfer or a spot face or anything onto the hole? Is it going to be full depth, or am I going to be shortening the hole at all? So you can still customize it once you've created it. It's not like you're stuck with it, but this gives you that ability to recognize the features quickly, efficiently. And now when I simulate, it's going to do all my automatic features, but then it also will do my custom features that I just created. So we'll simulate that all the way through. And it does that pocket. So if I spin this around that side, you can see that it did the pocket on the side there. With those 3 holes, that all looks good. And again, don't forget, NC code is done. It generated it automatically for me as I go. I don't have to keep generating it in the background. It's just going to handle that, and I'm ready to run. So really the big things with FeatureCAM is, obviously it's going to save you a ton of programming time, but it's not just selecting tools or selecting features. It's also selecting your feeds and speeds. It allows you to automate your feature recognition as well as fixturing. So maybe you want to really quickly create a fixture. I showed you that fixturing add-in. That's going to save you a ton of time, but also make your toolpath safer. And then it also allows you to automate the setup on the machine and the simulation of the machine. And you still have that full flexibility. So if you want to go in and program each feature individually by yourself, you can do that. If you feel like you need to have that level of control for this type of part, you can do that. You don't have to let the software do everything for you. And the other thing that it automates is the NC code generation. It chooses this post-processor when you list it as your primary option for this machine. It generates it for you in the background. It gives you a machining time. So if you're just getting an estimate, a quote together, you can do that in a matter of minutes. And then you're back onto your regular production work. So it's going to save you time on the front end when you're quoting. It's going to save you time in process, And obviously, you're going to be doing fewer model reworks and really streamlining things with FeatureCAM. And keep in mind, I showed a milling workflow here, going through some different setups for a 5-axis part. The same rules apply when you're just doing a simple 2-axis milled part or a turned part. It's just basically going to choose the correct strategy for that feature, and if you need to, you can go back through and customize it. But it's built to really automate. That's what it excels at. So if you feel like you're doing a lot of the same part or you're using a lot of the same strategies all the time on your components, FeatureCAM is definitely going to be a good fit. If you just want to speed things up, maybe you feel like you can improve your production times and your run times, this is going to be a good fit. Or maybe you got a new machine and you feel like you're not using every single aspect of the machine because your software can't handle it, or you don't feel comfortable programming that new machine. Again, FeatureCAM is going to be great at taking you to that next level and making it easy to learn for new programmers, but also making it a safer process for everybody. So hopefully that was informative. We'll go ahead and kind of wrap things up with FeatureCAM there. We will be sending out this video recording as well. But for now, if there are any questions, Lori, if you want to go ahead and send those over to me, we can kind of go through a few questions before we